Welcome to Teacher Tania's channel. I am just so incredibly excited you're hanging out with me today because we are going on a totally mind-bending journey into the very building blocks of math. Think of this explainer as your secret map to understanding how every single number you've ever counted, added, or multiplied is actually built completely from scratch. Today, we're putting on our math detective hats to explore prime and composite numbers. And honestly, whether you're a math whiz or just starting to unlock the secrets of multiplication, this explainer is going to completely change the way you look at numbers. So grab your notebooks, bring your curiosity, and let's see the math world in a whole new light.
Okay, let's just jump right in and imagine something absolutely massive. I want you to picture the entire universe. In science, we know that everything around us, the stars, the Earth, literally the screen you're looking at right now, is made up of these tiny, unbreakable pieces called atoms. Well, numbers are exactly like a physical universe. And guess what? Math has atoms too. These mysterious mathematical atoms are what we call prime numbers, and they literally combine to build absolutely every other whole number that exists. But why does this even matter to us? Well, understanding these building blocks is how we actually use math out in the real world. For example, these exact numbers are used by computers every single day to create secret codes that keep your passwords, your favorite video games, and your family's information completely safe online. They're the hidden foundation of the whole digital world.
So what actually is a prime number? The definition is incredibly simple. A prime number is a positive whole number with only two factors, the number 1 and itself. Let's do a super quick refresher for my 5th grade math detectives. What's a factor again? Factors are simply the numbers we multiply together to get another number. So if a number is prime, it means you cannot break it down any further. There are absolutely no other numbers in the entire world that can multiply together to make it, except the number 1 and the number itself. It's unbreakable, it's solid, it is a prime math atom. Let's look at a few real-life examples so you can see exactly what I mean. Take 3 classic prime numbers, 2, 7, and 11. Let's focus on the number 7 for a second. If you try to think of 2 whole numbers that multiply to make 7, you're going to get stuck pretty fast, right? I mean, you can't use 2 or 3 or 4. The only way to make a 7 through multiplication is 1 times 7. It only has 2 factors, 1 and 7. The exact same thing is true for 11. The only way to build an 11 is 1 times 11. And look at the number 2. It's tiny, but man, it's mighty. Its only factors are 1 and 2. These are true prime numbers, pure, simple, and completely unbreakable. Now, watch how this builds into something even bigger. If prime numbers are tiny, unbreakable atoms, then composite numbers are like the larger, complex molecules built out of those atoms. A composite number is simply a number that has more factors than just one and itself. The word composite actually means made up of various parts or elements. So whenever you see a composite number, I want you to immediately think to yourself, I can break this number down. There are a bunch of different ways to build this number using different multiplication facts. So how do we actually figure out if a number is a mysterious prime atom or a big composite molecule? We use our factors as clues. Let's walk through this step by step. First, let's pick the number 15. Step 2 asks, does it have factors besides 1 and 15? Well, let's use our multiplication brains. We obviously know 1 times 15 equals 15. But wait, skip count by 5s with me. 5, 10, 15. Yes, 3 times 5 also equals 15. Because we found a 3 and a 5 hiding right there inside of 15, we instantly know it has more than 2 factors. And because of that, 15 is for sure a composite number. Boom, you just cracked the code. And this brilliantly shows just how many building blocks some of these numbers can actually have. Check out these 3 examples of composite numbers. We already saw 15, which has the factors 1, 3, 5, and 15. But look at the number 4. Even though 4 is a super small number, it's composite. Why? Because you can make it with 1 times 4 and 2 times 2. So its factors are 1, 2, and 4. Now look at a bigger number, like 20. Wow, 20 is a very busy molecule. To build a 20, you could multiply 1 times 20, 2 times 10, or even 4 times 5. It has 6 different factors. That makes 20 a really strong composite number. The absolutely crucial point here is seeing them side by side to really understand the difference. We have our prime hero, the number 7, standing completely alone. Just 1 times 7. An unbreakable atom. Now compare that to our composite molecule, the number 15, which is built totally differently. It's a combination of 1 times 15 and 3 times 5. When you put them right next to each other like this, you can visually see the rule at play. Prime numbers only have one single way to be multiplied, while composite numbers have multiple ways. It really is that straightforward once you start looking at the factors. Now, I have a little confession to make. In the math universe, just like in any great story, there are always a couple of rule breakers who just totally refuse to fit into any category. I want to introduce you to the biggest anomalies in our entire number system, the numbers 0 and 1. These two are the absolute wildcards of the math world, and they play by their very own set of rules. You might be wondering, Teacher Tania, why aren't they on the prime list or the composite list? Well, let's uncover this mathematical mystery together. Okay, get ready for some mind-blowing fun facts straight from our source material. The numbers 0 and 1 are neither prime nor composite. No way, right? But think about why. Remember, a prime number must have exactly two distinct factors. The number 1 only has one factor, the number 1. It doesn't have two, so it can't be prime. And it certainly doesn't have more than two, so it can't be composite either. It's just entirely in a league of its own. Also, here's a really cool secret about even numbers. All even numbers except for 2 are composite numbers. Why is 2 so special? Because 2 is the only even number whose only factors are 1 and itself. Every single other even number in the universe, 4, 6, 8, 100, a million, they can all be divided by 2, making them all composite. Let's pull back and look at the big picture for a second. This incredible chart is showing us every single prime number within the number 200. Just look at all those unbreakable math atoms. Finding prime numbers is honestly a lot like being an astronomer mapping out the stars in the galaxy. At the beginning, they're clustered really close together, 2, 3, 5, 7, 11. But as the numbers get bigger and bigger, the prime numbers get way harder to find, hiding out among a massive sea of composite numbers. But here's the magic. If you take any composite number in the world, no matter how huge, you could break it down again and again and again until you are left with just a handful of these exact numbers we're looking at right now. These primes really are the foundation of everything. All right, math detectives, you've learned the hidden secrets of the math universe, you've met the unbreakable atoms, and you've discovered our rule breakers. Now, it's your turn to show off what you know. I have 2 challenges for you to solve today. Number 1, is 9 prime or composite? And number 2, is 13 prime or composite? Use your factor clues, think about everything we just learned in this explainer, and drop your answers right down in the comments below. I seriously can't wait to read them. And before we go, here's a crazy thought to chew on. Mathematicians are using super powerful computers to hunt for brand new prime numbers right now, and the largest one discovered so far has over 24 million digits. Can you even imagine? How big do you think the next math atom will be? Until next time, keep exploring, keep questioning, and always remember that every huge problem is just built out of smaller, unbreakable pieces. See you on the next explainer.